Have you ever been faced with the challenge of determining the size of generator that will be adequate for your establishment or even for your home? Have you also wondered whether the size of generator that you select will affect the amount of fuel consumption or the operating costs, running costs of that particular machine in your establishment? If your answer is yes to these questions, just hang on as we dive into two basic steps in determining the right size of generator for your use. So what are these two basic steps that you need to follow in getting the right size of generator for your use? The first step that you need to follow is to determine the load that you actually want to power with this generator. Then the second step will be to determine the generator size that will comfortably power this load. So these are the two basic steps that you need to undertake in selecting the right size of generator. So whether you are selecting generator, as you can see, for your company, your establishment, or for an industry, or you are making selection for a generator for your home, okay? So these two basic steps, they are the steps that you need to take in determining the right size of generator for your establishment or for your use. So now let us dive into the first one, that is determining the load requirement. That is the amount of load that you have that you want to power with the generator. So if you look to the right of your screen now, you will see a table with about 5 columns, okay? So this table can serve as a guide to you. What you need to do first is to list all the equipment on this column that is titled equipment or device. List all of them on this column. All the equipment that you actually want to power with the said generator. Then the number of such equipment will come under the second column, or the third column rather. Okay, that is the quantity, the number of them that you actually want to power. Okay, we will see all of this as we go along. So once you develop that list, that is called the inventory of equipment that you have that you want to power with the generator. So that is the first step that you need to, that is the first thing that you need to do. List the equipment or the devices that you want to power with the generator. So if it is your home device, okay, you list them: your gas cooker, the ones that have heater, your refrigerator, your television, laptop, air conditioners, printers, and what have you. So you list all of them under this column. But if you are actually determining the amount of load, okay, in a factory or for your company or for an industry, the same thing too. You list all the loads that you have here: printing machine, electric motor, pumping machine, conveyor, drive motor. You understand? All the lightings, okay? You list them under the equipment, and the quantity too, you also list them here, okay? So the steps, whether for residential, commercial, or for industrial purposes, they are the same thing. So next, what you need to do is to determine the power rating or ratings of each of these equipment. So usually the power ratings, you can find them on the nameplate of this equipment, either in kilowatts or in watts, okay? So you will now look for the power rating on the nameplate and fill it on this fourth column. against the equipment itself. Okay, so if we say maybe we are looking at lightings as an example now, say the light we have one, then that is the quantity is one, then maybe the light is 1,000 watts light, so we'll have 1,000 here. Okay, then the total will be 1,000 watt. But if we have two of such lights, that will mean that here will be 2,000 watt. Or if it is air conditioner, remember the air conditioner will come in horsepower, so you have to convert that horsepower to wattage. Okay, then if you have the wattage here times the number of such air conditioner that you have in your home or in your facility, the total will record the total here. Okay, so this is how you make the inventory of the equipment that you have with their power rating. So like we said, in making this inventory, the nameplate is where you get the power rating from. Okay, these are examples of nameplates. So when you look at the nameplate of the equipment, you see this is in horsepower. Are we getting it? So this is the horsepower rating. So this is what you will have. You convert it to wattage. Okay, and then you place it here. Okay, then if maybe you did not have this, you multiply the full load current, which is 34.9 amps times voltage. Since it is three phase, you multiply with root 3, okay, to give you the wattage, in case you do not have the horsepower, either is the power rating on such a nameplate. So this is also of a nameplate. You see, like this now, the wattage is 14 watts. So against this particular equipment, you write 14 watts here. This also is that of an oven. Look at the wattage. If you look at behind of it, a microwave oven, okay, this is where you have the wattage. So there is 700 watts. So you put your 700 watts under this column. So what you have just done, or what you are doing now, is taking inventory or making an inventory of all the load that you want to power and the power rating of all of such loads. Okay, so this is an example of what we have been discussing. Imagine, just assume that these are the loads that you want to power with the generator. You have the computer, you have your monitor, you have your printer, you have your lighting and your air conditioner. These are the quantities that you have. Okay, then these are the individual wattage rating or power ratings of these equipment that you want to power. Then these are the totals. Okay, here we have the sum total. So here we have 16,000 watts, which is 16 kilowatts of load as an example. It could be more than this, it could be less than this. Okay, if we are looking at maybe a factory, it could be far higher than this. But this is the basic step in determining the load requirement. Okay, now there are some situations that you may not have access to the nameplate, or the nameplate is just not there. So how do you determine the load requirement? So if you are looking at your maybe your home now, for example, what you need to do is to put on those loads. When you have public power supply, you put on those loads. Okay, when those loads are on, you can go to your distribution board. Then you take the current reading with a clamp on meter or a current meter. Okay, either of the load directly, or you can place it here maybe with a flexible current meter like this. You place it here to get the current reading, the amount of load that is the amount of current that those load that you want to power will exert on the power system. So when you get them, okay, you multiply by the voltage. Are we getting it? You multiply by the voltage to give you the power rating that will be required to power those loads. Okay, that is the current from your amp meter times the voltage. So if it is a three-phase system, remember to multiply by root 3. Okay, so if you have maybe a switch jar in such facility, you find the current reading on those, and if you are lucky, you also have the power meters on the switch jar. Are we getting it? So once you have those power meters, the wattage reading, you just get it directly. If not, take the current reading and multiply it with the voltage reading. If it is three phase times root 3, okay, that will give you the wattage that you want. Okay, so this will give you the size or the power of the general load, not the individual load as in this case. Are we getting it? So that will give you, this is a straightforward and a faster means of getting the power rating. If you have any question as to this, you can also leave a comment below in the comment section. We'll address all of this with you. Then you can also do that in your industrial facility. Take the current when all the loads are on, take the current on each phase and multiply it. Since it's three phase, multiply it with voltage and root 3, okay, to give us the power rating. So now you have gotten the total wattage, okay, that you need, that is the total power, the total load that you need to power with the generator. So what you need to do next is to think of the kind of load that you will be powering. Remember, inductive loads during startup, they consume more than what they use during their normal running. So you have to have that at the back of your mind when determining the size of generator. So since during startup, this equipment, these inductive loads, they have a starting current that is higher than their normal current. You have to take note of that when considering the power rating of this electric motor. Are you getting it? So if you know that the starting current is say 1.5 times, okay, more than the normal current, or 2 times the normal rated current, of course you want to add that. What that means is that if this is the motor now, for example, say the motor is 100 watts, okay, that is what you got in your calculation. So what you need to do is to double the wattage to accommodate that starting current. So instead of using 100, you'll be using 200 watts. Are we getting it? Because we don't want to have a situation where our generator will be dragging at the end of the day during normal startup of those loads, or tripping off during normal startup. So you want to accommodate those. So put in mind, consider the types of load, especially the inductive loads, okay? Then you also want to consider the power factor of those loads, okay? You want to consider the power factor. Remember, the desired power factor should tend to 1. Are you getting it? So those fractions less 1, they are like wastage, okay? So you want to accommodate those wastage, or else your generator will not be able to carry the load. So as an example, maybe you have a load of 2000 watts, okay, and let me say 1000 watts for convenience sake. for the sake of calculation, okay? Maybe you have a load of 1,000 watts, and the power factor of that of the system, of the load, is 0.8%. Is 0.8, I mean to say. So if it is 0.8, that means that 20% of whatever you feed into that load will be wasted. Are we getting it? So in that case now, instead of you powering that load with 1,000 watt generator, you need to power it with 20, that is 1,200 watts generator to accommodate that 20% loss. Are we getting it? So that is one of the reasons why when we are selecting load or buying load, we want to take those that are of higher efficiency or have higher power factors. Okay, so that we will not be having wasted energy in our system. So you have to consider the power factor. The next thing that we need to do is to determine the demand factor. Remember, these loads that we are looking at, they will not be on all the time. There are times we'll be using them, there are times they will go off. So that is what we want to determine. How much time of the day, of the working day, that such loads are used. Are you getting it? So we want to know that, and know the time that we know majority of the load will be on, the amount of time that majority of the load will be on. So what we need to do is that time when majority of the load will be on, we want to determine the maximum, that is the demand, that will give us the maximum demand. Okay, that is the maximum wattage load on the system. So once we get that maximum demand, okay, we will now divide it with the sum total. Imagine, like in this case now, we have the total load to be 19,000 watts, okay, or 19 kilowatts. Then maybe the maximum demand that we may have on the system, all these loads, they will not be on at the same time. From observational analysis, we discover that most of the time, that is the maximum demand that we have is, say, 10,000. Are we getting it? 10,000 watt, that is 10 kilowatts. So that becomes our maximum demand into this demand factor calculation. Okay, so it will now be 10,000 upon 19,000. That is 1 over that is 10 over 19. Okay, so that becomes our demand factor. So that demand factor, what do we need to use it for? So, but remember that if you select a larger size generator without considering the demand factor, remember that fuel consumption, the larger the generator size, the higher the fuel consumption. Okay, and not only that, the fuel consumption will be higher, the maintenance cost also will be higher. So this consideration is meant basically to optimize the selection process, or optimize the generator that we have in our facility. Okay, so remember too that the possibility of growth will be there. So you need to balance all of these considerations, okay, for us to get the right size for our facility. Not that tomorrow a growth that you did not envisage will come, and then the generator will become undersized for your load, and that will now force you or your establishment to want to go and buy another generator. So if you envisage a growth, okay, in your load size, you have to factor that in. Okay, maybe put in 20% for future growth or 30% for future growth, as the case may be, and then use that. So what this means is that once you have gotten your total demand, as you have seen here, assume that the total demand is 19,000. Okay, then you say, okay, let me factor in 10% growth or 20% future growth. Okay, so you now work out 20% of that 19,000 and add it to 19,000 to accommodate that future growth. Remember that your demand factor, you have considered it o, but that's important so that you do not oversize your power generator. So now you have gotten the load requirement, okay, the amount of load that you want to power. Let's say you have determined it to be 20 kilowatt. Yes, 20 kilowatt, that is 20,000 watts. Okay, now you want to determine the right size of generator. The generator that is required will be required to power that to 20 kilowatt. So what you need to do is to first look at the generator that will have sufficient capacity. Are we getting it? Generator that will have sufficient capacity to comfortably power that 20 kilowatt load. Okay, so the rule of thumb is that the generator should have a capacity that is more than the expected load. Are we getting it? Because you do not need to load your generator more than 80% of its capacity. What this means is that if you have a 100 kVA generator as an example, you cannot load that generator more than 80 kVA, give it more than 80 kVA of load. Okay, so which means that the load, the generator will be 20% higher than the load, or will be able to deliver power that is 20% higher than the load. So you choose generator with the sufficient capacity. Then the next step is that you need to consider is the overload capacity or surge capacity of that your generator. Okay, in most cases that 20% allowance that we discussed earlier will definitely take care of this overload consideration. In case you accidentally overload, maybe you have all the loads on and then a motor picks up or your 3 air conditioner comes up at the same time, you see that will add additional loads, okay, to the generator. So you have to consider the overload capacity. You will see that in the data sheet of the generator as we have seen, as you can see here. So if you look at your screen now, you see that say there is no limitation to the annual hours of operation, and the model can supply 10% overload power for 1 hour. So if this can accommodate what you are expecting, fine. At that power rating, this generator will work perfectly. So the next that you need to know to determine, now you have determined the power, then the voltage requirement, the frequency, okay, you need to make sure that they are compatible with that of your system. So like if your system is using 415 volts, the generator should be able to give you that 415 volts. If it is 50 hertz, should be able to give you that 50 hertz, or 60 hertz should be able to give you. So all of those, you see them on the nameplate. Okay, so this is the power rating, 15,000 kVA. Then this is the voltage. Okay, it's a medium voltage generator. This is the amount of load that it can withstand. Okay, then the frequency here is 60 hertz. So if your installation is a 50 hertz installation, fine. If it's a 50 hertz installation, it means that the frequency here must be 50 hertz. Okay, so this is the nameplate of the generator. So you also need to look at the generator efficiency. Remember, the efficiency will determine the amount of power that will be available, the amount of this power that will be available to you. Are we getting it? So you have to determine the efficiency, okay? And one factor that affects the efficiency is the power factor. Are we getting it? So which means that if the efficiency is same, you also see it in the data sheet. If it is say 98%, okay, it means that 98% of this power rating on the nameplate will be available for your use. And remember that 98%, okay, it is 80% of it that we need to use. Remember. So then we also need to consider how easy it will be for us to install this particular generator that we are selecting in our facility. Okay, whether we have enough space for what we are seeing in the data sheet, because the dimensions will be there. Okay, what it will take us to install. Then the maintenance and operations. In making the selection too, we want to consider maintenance and operation. We do not want to consider only price alone, because we may end up spending more because of unavailability of spares for maintenance. And the generator too may be cheap, but if you look at the diesel consumption from the data sheet, those are things that you need to look at. The diesel consumption, the amount of fuel that it will consume when it is loaded maximally. Okay, all of those, then the efficiency too. Those are things that you need to look at. Those that are more efficient have parts that are readily available. They may be more expensive, but the life cycle cost of the generator will be far, far lower than those cheaper generators. So we want to consider the operations and maintenance costs. Then once after we have done that, then we can now choose the size of generator that fits all of these requirements. Okay, so here we have an example of a data sheet. This is the generator set, which is the electrical part. Then we have the engine, which is this. Okay, they are in this soundproofing box or container. So here you see the frequency rating 50 or 60 hertz. Okay, so the one that matches your system is what you select. So if it is say 50 hertz, 380 volts, that 380 volts will be, then this is the output power, either in kilowatt or in kVA. Are we getting it? So if we are looking at say 1800 kVA, okay, this is the power that will be available for us to use. Then when you come to the engine, you see the output power of the engine. Okay, then you see the fuel consumption that we discussed earlier. Are we getting it? This is the fuel consumption in liters per hour. Okay, so you have to compare this with that from other supplier or other manufacturer to determine the one that will be good for you. Okay, the one that will be consuming less diesel or less fuel and still be able to give you the same amount of power, I think is better for you. Okay, so you consider every other things and then make your final decision and select the generator that you actually want.